Hey guys, hoping all is well with everyone. So in this video I'm going to be discussing and introducing lesson 1.5, and I kind of want to keep this kind of its own video for the introduction. The lesson 1.5 is all about dividing fractions by fractions, and this can be a very daunting, very challenging topic. And the reason for that is dividing fractions by fractions, up to this point, a lot of the division that we have seen have just been whole numbers divided by whole numbers. We have not seen up to this point. What we will see very shortly is the idea of a complex fraction, which are two fractions divided by each other. But what we're going to do here is we're going to see that the irony of solving our situation of dividing fractions by fractions involves multiplying and using that operation. So what I'm going to do is first discuss the story problem and use the visual aid to kind of explain how we divide fractions by fractions. And then I'm gonna go into a little bit more detail and a little bit of algebra to show why dividing two fractions is equivalent to multiplying by what is known as the reciprocal of the divisor. It sounds very technical, but let's definitely we'll go step by step in going forward. So let's go ahead and talk about the question at hand here. So it says a granola bar was cut into 6 equal pieces. What I really like to kind of hammer home when it comes to story and word problems is highlight the very important information that usually involves any numbers, anything that you feel gives you very pertinent information that you could use to assemble a mathematical expression or equation. So 6 equal pieces, that's very important. Oh, so I want to use red here. And it says someone ate part of the granola bar so that 2/3 of the original bar remains. So the most important part of that whole sentence is that 2/3 of the bar remains. Now the next one is the question. It says how many 1/6 parts are left? This doesn't really, I'm not saying it's not important, but the question itself is very important. But in terms of the information, it doesn't really offer too much. But that in itself is what we're looking for. So that is very important in it by its own. Use the picture to draw a model to represent and find 2/3 divided by 1/6. Okay, so a lot of times one of the challenges with story problems is that there is other information that you can get from it, but it's not there word for word. So the first thing that we want to do is kind of fill in the missing pieces, so to speak, by using kind of some logic here and approaching it with a visual aid. So let's look at that. So the first sentence says that it was cut into 6 equal pieces. So as we see, there's 4 pieces of granola here. So I'm going to represent 2 more pieces, but they're gone. But it's still important to represent that, because originally we had 6 1/6 pieces, giving us a whole bar. So I'm going to represent each of these as 1/6 as well. Alright. The next thing that we want to kind of determine is if 2/3 of the bar is left, then we want to kind of represent 2/3 as a fraction with a denominator of 6, because we're questioning how many 1/6 parts are left. So what we're going to do is we're going to find the equivalent fraction of 2/3 with a denominator of 6. So if we multiply the top and bottom, and if we want a denominator of 6, we have to multiply the 3 by 2. So we're going to multiply the top by 2 as well. This is how we find equivalent fractions. We multiply the fraction by a common ratio of a whole number or anything, and it doesn't change the value. It just becomes an equivalent fraction. I'm not positive if any mathematical properties have been discussed yet, but you'll see going forward that this is the multiplicative identity of multiplying by 1. 2 over 2 is equal to 1, and it doesn't change the value, it just changes the physical representation of it. So 2/3 are equal to 4/6, but it's important for us to represent that as 4/6 because the question at hand again is asking us how many 1/6 parts are left. And if we think about it, we just answered the question. Because if we have 6 over 6 pieces to start with, and one person ate 2 times 1/6 pieces, then that's going to be equal to 6 over 6 minus 2 over 6, which is equal to 4 over 6. But if there's 4/6 left, then that means that we have 4 times 1/6 pieces. Okay, so again, we can conclude that even based on the picture as well, as we see those 4 equal granola pieces left over. So what we're going to do is we're going to take that 4, which is our resultant of how many 1/6 pieces are left, and we're going to compare it to our answer that we get when we divide these two fractions. So let's go ahead and do that. So if we have 2/3 divided by 1/6, this essentially introduces the idea of a complex fraction. It usually occurs when it's a one rational number over another one. Now keep in mind that a rational number is just a number in terms of where it can be written as a ratio of two whole numbers, but in this case we have two of those situations. So it's like we want to kind of clean this up, so to speak. The way that we're going to do that is we're going to use multiplication. So what we want to essentially do is we want to get this denominator to equal 1. The reason for that is anything divided by 1 is just itself. So 2/3 divided by 1 is going to be equal to 2/3. But we have to multiply the top and the bottom by what is known as the reciprocal of the divisor. So let's talk a little bit about some terminology review here. Remember, the numerator is always your dividend. It's the number being divided. Your divisor is the denominator. The divisor is the number that's doing the dividing of the dividend. And then the quotient is your resultant. So what we're going to do here is we're going to multiply by the reciprocal. The reciprocal of a, let me put some terminology here too. So the reciprocal is the value you multiply by an original number to result to equal 1. So what you would do is you would multiply the first number by the inverse, or the flip-flop, for lack of a better phrase, fraction. So what we'll do here is we'll take 1/6 and we'll multiply it by switching the numerator and the denominator. So we'll multiply this by 6 over 1, and 1/6, and the reciprocal of 1/6 is 6. But it's always helpful in these kind of cases to represent 6 as 6 over 1, or as a fraction. Remember, you can represent any whole number as a fraction with a divisor of 1, because any number divided by 1 is just that number. So going back to the reciprocal here, just to show the mathematical proof of it equaling 1, if I multiply 1 by 6, I get 6, and if I multiply 6 by 1, I get 6. 6 divided by 6 is equal to 1. Any value divided by itself is going to be equal to 1. Now, that's very important, because essentially going forward with this is going to be why the multiplication of the reciprocal is equal to dividing the fractions. So what I'm going to do is I'm going to multiply both the numerator and the denominator by those reciprocals of that divisor. So reiterating that, I'm going to multiply the numerator and the denominator by 6 over 1, because that is the reciprocal of 1 over 6. So at this point, we still technically do have a complex fraction. And at this point, it might even look a little uglier, but we're going to do some huge cleanup here and housekeeping. Go ahead and multiply the fractions through. Remember, when you multiply your fractions, you're just going to multiply numerators and then the two denominators, and that's your resultant. We just have to do it twice here because it's the multiplication of two sets of two fractions. Okay, so 2 times 6 is 12. 3 times 1 is 3, so that is our numerator in itself. 1 times 6 is 6. 6 times 1 is 6. Now we're going to do even more cleanup here. We're going to simplify this. 12 divided by 3 is 4. And 6 divided by 6 is 1. And our resultant, again, shows up as 4 1/6 pieces. Now, what I want to highlight here is that, again, we're kind of using that multiplicative identity of 1, because what happens essentially when we multiply both the numerator and the denominator by the reciprocal is 6 over 1 divided by 6 over 1 is just 1, because 6 divided by 6 is just 1. So again, we're not changing the value of this original complex fraction. We're re-representing it in a physical way to where we eliminate the complex fraction and find a resultant. And the way that we do that is that multiplication with the reciprocal of your divisor. So that's the whole nitty-gritty of why we multiply by that reciprocal when we have the division of two fractions. We want to eliminate that complex fraction to where our quotient is a rational number, which is again two whole numbers that are in a ratio with each other. Okay, but let me show you the algebra just to kind of introduce it to you. Let me see here. So I'm gonna do it in blue here. So algebraically speaking, if we have A, B, C, and D, where those are just numbers, if we have A over B divided by C over D, this is going to be equal to A over B divided by C over D. Now in this first step, I really haven't done much. I've basically represented the left and right kind of division view with a complex fraction view. I haven't really done anything other than that. But what I'm going to do now is I'm going to multiply the top and the bottom by that reciprocal of C over D. Now remember, even though these are variables, we can still find a reciprocal because we just want to represent the C over D multiplied by something to equal 1. And that's just going to be flip-flopping the numerator and the denominator. So I'm going to do A over B divided by C over D, and I'm going to multiply, I'm going to use red here, I'm going to multiply this by D over C over D over C. So now, in essence, before we go ahead with this multiplication, we kind of have like two complex fractions times two complex fractions. And it seems like it becomes a mess, but in this next step, you're going to see a lot of cleanup here. Let's go ahead and multiply everything through, okay? So, I'll use green for this. This is going to be equal to, I'm going to leave everything as just multiplied out, kind of like so. So this is going to be A times D over B times C over C times D, and D times C is just CD over CD if you reorder the letters. Regardless of what C and D are, they're the same values in the numerator and the denominator. So that's just going to result in 1. Okay? Let me see if I can make enough room here. I want to be able to represent that. Use this. So this is going to be CD over CD. Okay? And that's just going to be equal to, as a final resultant, A times D over B times C all over 1. So now we have officially eliminated our complex fraction because that A times D over B times C has a divisor of 1. Anything with a divisor of 1 is just going to be that value. So your resultant is just the fraction A times D over B times C. And again, A through D are just values, could be anything, just algebraically representing them as, could be whole numbers, and we'll kind of infer whole numbers for this situation. But just to show you guys the, and again, if we did that algebra, or if we go back, we do get that 4 over 1 from that story problem. So this algebra just shows us that if we divide two fractions, this is the same as multiplying by the reciprocal, because originally we did A over B divided by C over D, and our resultant ended up being A over B times D over C, and D over C again is that reciprocal of C over D. And that's the strategy that we're going to use going forward. And again, it does make things a little bit more efficient. A lot of times when we divide fractions by fractions, fractions a lot of the time are a value of less than 1. So you're almost thinking of doing long division with 2 decimals. So multiplying by the reciprocal makes things a little bit more easy with just multiplying. Okay? If you guys have any questions about this, please don't hesitate to reach out and ask me. I hope this helps you out, but I will definitely be continuing with the pages of Lesson 1.5 and dividing fractions by fractions using that strategy discussed in this video today. But I hope this helps you guys out, and as always, please take good care of yourselves, and thank you so much for watching.